Hey everybody, this is Miss Lee, and I'm going to go over the SGO review with you all. A lot of this stuff we haven't looked at since the beginning of the year, so we're going to jump right in with polynomials. The first thing we looked at pretty much with polynomials was factoring, and so some of the things you want to consider when you're factoring are finding a GCF, using the Xbox method, and thinking of those special cases. And those special cases that we had were like the difference of squares, perfect square trinomials, stuff like that. So one of the things to think about is that our polynomials are in this form ax squared plus bx plus c. So if we're using the Xbox method, we want to multiply a and c together and find two numbers that multiply to this value and add to b. So that's how the Xbox worked. So if we're looking at number 1, we have 50x to the 6 minus 72. I want to see if there's a GCF I can factor out. Both of these numbers are divisible by 2, so I'll just start with factoring 2 out. And now you can see my new expression, and I have a special case. I have a difference of two squares. 25 is a perfect square, 36 is a perfect square, and x to the 6th, because it has a even exponent, that is also a perfect square. So when we had perfect difference of squares, it was in this form a squared minus b squared. And so when we factor that, we end up with a plus b, a minus b. And how do I find my a and b? Well, 25x to the 6th is my a squared. So I'm just going to take the square root of that. 25 square root of that is 5. Square root of x to the 6th, I'm just dividing the exponent by 2, so I get 5x cubed. And for my b squared, I'm just going to take the square root of 36. That's 6. So when I find this a value and b value, 6, I can put it into this setup. X cubed minus 6. And that's it. The next one takes up a step further in solving polynomials. So we are going to do some of the same steps, or we want to factor this first, and so I'm going to look for a GCF again. Both of these numbers are divisible by 3x, and when I divide 3x out, I'm left with x squared minus 16. Since this is equal to 0, I'm using the zero product property, where it tells us if we have the product of two numbers, as long as one of the numbers equals 0, the whole product equals 0. So I have two different things multiplied together that equal to 0. As long as one of these equals 0, the whole thing will. So I'm going to set each of these factors equal to 0 and solve for x. So x equals 0 is one of my solutions. I'm going to now use this one. And here I'm actually solving with square roots, because I get x squared equals 16. Take the square root of both sides, and that gives me x equals plus or minus 4, because we are taking the square root with solving, so remember that you have both the positive and negative version as an answer. Another way to do this and solve is to just continue factoring, because you can see the difference of two squares, and we end up with x plus 4, x minus 4. So you can set each of these factors equal to 0 as well, and you'll get that same answer. Oh, sorry, not that. X equals negative 4, x minus 4, x equals 4. So that's another way to solve and get your answers. Last part of polynomials, dividing a polynomial by a binomial. So when we looked at this section, we used synthetic division. synthetic division had a setup with this kind of L shape. So we put our function over here, and we want to count for every degree of x. So I'm going to just write out all the degrees of x on top so I don't forget any, starting with x to the fourth and going all the way down till my constant. So x to the fourth coefficient is what I'm putting in here. These numbers are the coefficients. So I have 1. I have no x cubed terms, so I do have to put a 0 in as a placeholder. 3, -7, and -20. So with synthetic division, there's a number that goes out here, and that number is taken by the binomial that we are trying to divide. So I want to set this equal to 0, solve for x, and that's the number that goes over here on the left. Now the actual synthetic division process. The first step is just to drop this number down. And this number then gets multiplied by the number on the top left. Multiply. So I'm multiplying this number together, and I'm going to then bring it up. So 2 times 1 is 2, and that number gets brought up here. So after we bring the number up, you are just adding down all of these columns. So 0 plus 2 is 2. Now I'm starting back over and multiplying with that top left number again. 2 times 2 is 4. I'm adding. 2 times 7 is 14, and I'm adding. 2 times 7, 14 again. And finally I get -6. And the last number is going to be your remainder. So I'm not quite done because I have to actually come up with an answer. Since we started with x to the fourth and we divided by an x, our answer is just going to be 1 degree less. That first number represents the coefficient for the first x term. So x to the fourth, I'm taking 1x away, I end up with x cubed. X cubed, coefficient of 1, plus 2, x squared, I'm just dropping an x for each term, plus 7x, plus 7, my constant, minus 6, the remainder goes over the term that we divided by, and we get our answer. Okay, so that's it for polynomials, but we are going to now look at our problems with trig. So we started with right triangle trig and looking at the ratios for those specific trigonometric functions. What did we use to remember these ratios? SOHCAHTOA. So if this is my angle, I want to label my sides, and I have the opposite side opposite of the angle. The adjacent side is touching the angle, and the hypotenuse is always that slanted side across from the 90-degree angle. So I have values for O and A, which means I can fill out my tangent, 6/8. I want to simplify that. But I don't have h, so I can't fill in sine or cosine yet. If you remember right triangles, you can use Pythagorean Theorem to find that third side. So since we are solving for the hypotenuse, we are going to be solving for c. So I get 36 plus 64 equals h squared. My hypotenuse is 10. So now I can fill in the rest of my trig ratios of opposite over hypotenuse and adjacent over hypotenuse. And that's how you find those trig ratios. Next up, you can see is an application problem where we used the angle of elevation. So a pole is leaning against a wall and it's 15 feet from the base. If the angle of elevation from the ground to the base of the pole is 63 degrees, I want to find that length. So I want to label the sides. I've got the opposite, hypotenuse, adjacent. I need to figure out which two sides are relevant to this problem. I'm looking for the pole length, so A and H. That means I'm using cosine. And something that I tried to ingrain in your brains was the setup for trig equations. That's going to be trig of our angle equals the ratio. So the angle always goes inside of the trig function. We're using cosine, so 63 goes inside cosine. I'm setting up my ratio, A over H, 15 over, let's say, X, and I need to solve. So remember, when we're solving for X needs to be in the numerator, it can't be in the denominator, so let's get rid of it in the denominator. Always multiply by the denominator to get rid of it, and we get X cosine 63 equals 15, and you get X by itself, and cosine never exists by itself, so we're dividing the entire cosine 63 out. X is equal to 15 over cosine 63. Make sure your calculator is in degrees mode so you can find that value. Since we are using degrees for this problem, just put that in your calculator, get the length of the pole out. So, last thing is unit circle. So, you all have your reference unit circle already, but just be comfortable filling out the degrees, the radians, and those coordinates for these values in the unit circle, the top half of the unit circle. Remember that our coordinates are cosine theta and sine theta. So cosine is x, sine is y. Over here, let's look at this one. If this is 90 degrees, and that means this is pi over 2 radians, my coordinates are going to be 0, 1 for that line of the unit circle. So I hope this was a good review. If you missed anything in class, you can reference it in this video. Don't forget to pause, rewind, and relook at anything that you missed. Bye!